Today I want to explain the mathematics behind linear regression in a very simple way. In my previous understanding, the main idea of linear regression is actually very simple. We just want to find the best straight line that fits our data points. Mathematically, the line is written as just y is equals to mx plus b, where m is the slope and b is the intercept of that particular line. So the entire problem of linear regression is basically about finding the correct values of m and b. First of all, imagine we have some data points. Like for example, we have x as the CGPA of a student and y as the package of that. When we plot these points on a graph like this, they will not lie perfectly on this straight line. Some points will be above the line, some will be below the line. So the question is, how do you choose the best possible line? So idea of the best fit line. The best fit line is a one of that passes closest to all of the data points. But how do we measure the closeness? For every point we calculate the error. Error means the difference between the actual value. Actually look at this point. This point has the actual value as here, but the predicted value is here. The gap between these two is basically called as the error. We will be finding the error of it like this: y minus y prediction. That is the error. And y is the actual value and y dash is the predicted value. Now error function, to measure the total error of all points, we created something as like cost function. Cost function can be written like this. This is the cost function. So what this means is, for every data point we calculate the prediction, subtract the actual value from it, and square the error of it. See, look, we have done square the error of it and add all the errors together. Squaring is important because errors become positive. Larger errors get more penalty. So our goal is we must find the j of m and like e of m comma b. That means the minimum error like of m comma b. That is, for example, we will be taking y is equals to f of x. That means if x changes, then the y value also changes. Here we have two things. We have slope and also intercept. We are doing a function. So if slope changes or the intercept changes, we will be having a change in total function of this e value. In simple words, we want a line where the total squared error is minimum. The error between this predicted and the actual, the distance, that error should be minimized. So how do we find m and b? How do we find the slope and the intercept? What do we do is, to find the minimum value of the cost function, we use calculus. How the calculus is performed here is, we will be doing dou e upon dou m. That is, like, we will be doing partial derivation of e upon, like, for slope we will be finding partial derivation, and also for the intercept we will be finding the partial derivation. Then we set them is equal to 0. This will help find the point where the error is minimum, this thing. So final formulas will be like, we will be getting, after all the derivation, like you can look at here, after derivation we'll be getting the final value as b is equals to y minus, like, y dash minus m x dash. Here y dash means the mean value of y and x dash means the mean value of x. And the other one, slope, will be this. This is the slope formula. So we will be getting after all the derivation is done. So these two formulas gives us the best fit line. The key idea of this was, assume a line, measure the prediction error of this, minimize that error, and calculate the slope of the intercept. And once we know the m and b values, we can predict the new values using this particular formula. So that is the mathematical intuition behind simple linear regression. The next step, we can also implement the Python code for this, and we will be doing some project using the linear regression. Stay tuned.